All right, so we're going to talk today about the unit circle. That's covered mostly in 6.3 and 6.4. And the unit circle we've already seen some of, right? That's just a circle centered at the origin with radius of a unit or radius of 1, right? So radius of 1, I'm going to do a terrible job of drawing this, but we can kind of see that it would look something. Whoa, that's not the best drawing anyone's ever made. There we go. Not the greatest thing. So this is a unit circle with radius 1. Because it's radius 1, right, we can sort of define these points as things that we know, right, because they have to be 1 unit away from the center. So we know these 4 points very easily. And I first want to talk about sort of some terminology for how we measure and how we talk about angles and some terminology. So we can have, with the unit circle, we're always going to measure angles starting with this positive x-axis, right? This is always the initial portion of our angle. And then if we want a positive angles are we go counterclockwise. I don't know. Is that one word? Oh, we'll throw a hyphen in there. Who knows? Counterclockwise, meaning, if I wanted to measure positive 60 degrees, I'd go 60 degrees this way. This would be positive 60. And negative angles, we can have such a thing. Negative angles, we're going to go clockwise. So if I wanted to measure negative 45, say, this right here could be negative 45 degrees. Notice that there could be multiple ways of measuring any given angle, right? In theory, 60 would be the same as negative 300, right? Negative 300, where I sort of went like this all the way around until I got to there, right? Negative 300 would be the same. Additionally, I could wrap myself around. This will be kind of weird to think about, and you might not really have ever thought about this, right? But this angle, I went 360 degrees around, and then I went 60 more, right? This angle is also equal, right? This angle of 420 degrees, 360 plus that later 60. Those are all the same. Okay, so we have these ways of measuring angles, okay, and that's great. We also have another unit system, just like our unit type, just like I could measure myself in inches or in feet or in meters, right? We don't have to use degrees here. So we're going to introduce this concept called radians. And we want to think about radians is if we were to take a walk around the edge of the unit circle, how far did we travel? So, right, we're walking around, how far did I have to travel to get here? And to answer that question, we're going to have to think about the circumference of a circle. Right, which is diameter times pi, and the diameter, of course, is just 2 times the radius times pi. In this case, the radius is just 1, so the circumference of this circle is 2 pi, right? If I were to start here and walk all the way around the circle, all the way around, it would take me 2 pi units to get around. So what that means is it would take me pi units to get to the other side, right? This could be 0 or 2 pi. And then we can sort of divide the unit circle up by that, right? If 180 degrees is pi, well, this has to be pi over 2, right? And this one would have to be 3 pi over 2. If we were to walk in a negative direction, right, we could say this was negative pi over 2 as well, right? If we were to walk this way, just like with our negative angle measures that we'd seen before. So we're going to cover this with our entire unit circle very shortly. Just wanted to introduce this and talk about ways to go from one to the other, right? So we know over here at this far end of the circle, right, that this is also 180 degrees, right? That makes sense that if you went all the way around the circle, you've gone 180 degrees. And we now know that it's pi. And we're sort of going to use that as our conversion factor. So if you told someone who is 5 feet tall and they wanted to know how many inches they are tall, right, you would multiply the 5 feet times a version of 1, right? That's 12 inches over 1 foot. Right? And then you would multiply the feet, sort of cancel, and you get 60 inches. That's how you would convert from feet to inches. Right? We're going to do a very similar thing. If I wanted to know, say, how far 90 degrees was, 90 degrees in radians, I would multiply by two equivalent things, right? I'd multiply by pi over 180 because these are the same. Over here, they're the same. And I would end up with pi over 2, which is what we said over here, right? That makes sense because this right here, this looks like 90 degrees. And of course, it is pi over 2, right? So those are the same thing. Similarly, if I wanted to go the other way, and I said, how far is, we'll do pi over 2 also. Pi over 2, how far is that in degrees, right? We would say 180 over pi, and of course we would get 90. So we can go either way just by multiplying by either pi over 180 or 180 over pi if I want to go from degrees to radians or radians into degrees. Okay, now let's go back and think about our unit circle and our coordinates. So we did this a little bit last week. Just a little bit, but today we're going to deal with it more in general than we did last week. So let's consider our unit circle again. Let's consider our unit circle, and let's think about some angle here, theta. Right? Remember, we're measuring positively this way. That's the angle theta, and again, radius is 1, and I'm going to I want to talk about this point right here where it intersects my unit circle, and we're going to call that A comma B. And our goal here is to find what A and B are in terms of theta. Okay, so I'm going to drop down an altitude, make a right triangle, and we remember from last week, I guess that was this week. All out of it. We remember SOHCAHTOA. And I'm really not going to focus on tangent right now. I'm going to focus on sine and cosine. And before we do that, let's fill in some values here. So if this point is A comma B, that means A is the x-coordinate, meaning this length here must be A, and this length here must be B. So then I could say that the sine of theta, by the way, we know that this hypotenuse is length 1 because it is a radius of the unit circle, right? I could say that the sine of theta was the opposite side from theta, B, over the hypotenuse, 1. Similarly, I could say that the cosine of theta was the adjacent side, A, over the hypotenuse, 1. Very similarly, right, we could say that tan theta was the opposite over the adjacent B over A, but we don't care as much about that. We really care about these two guys on the left. So from this, right, the 1 really doesn't matter. I know what B and A are. B is sine theta, A is cosine theta. So really, this point A comma B could really be written as cosine theta, comma sine theta. And that holds true for any theta we have. Any theta we have, I can write it as an ordered pair, cosine theta, sine theta, where it intersects the unit circle. Okay. And again, the way to remember that, remember we have our x-axis and our y-axis. And I really think the way to remember that, right, is that y goes up and down, right? And we sign up for things, right? So sine is related to y, cosine is related to x. But we will definitely play with this enough that that'll become sort of second nature.